The only section in Chapter 1 that we're going to cover is 1.4, and again, it's just dealing with factoring. That's the thing that, it's really a summary of Math 63. It's the, Math 61 from last semester, if you took it last semester. It is probably the most important concept in Math 61, so if you got to factoring, which hopefully everybody did, that's the concept we sort of take on into Math 63, into Math 15, which is pre-calculus, and eventually into calculus. That's the main focus of Math 61 besides solving an equation. Alright, so we're going to just quickly review this, and then we're going to jump into Chapter 2 to actually start solving equations and to get into those dreaded word problems as well. Alright, so factoring, just a quick introduction here beyond what the textbook has. Is reason why we have to do factoring is because we don't live in a linear world. We live in a world where things maybe go up and then come down, and there's a parabola or a quadratic equation. We have to be able to deal with those. So factoring is the thing that allows us to deal with anything that has a curve to it, literally. And so a ball going up, ball going down. Again, just quickly introduce you to a few more things here maybe. And this is the equation for it. And again, since you're just all going through Math 6, you guys already passed Math 61, you know this can be factored down to something like this. And so what it really does is it takes you from an equation that has x squared or maybe x cubed or t squared or t cubed, and it breaks it down into linear products, and that's what you want. Because remember, for Math 61 we learned really the only equations we can solve are linear equations. We can solve for a certain variable. So if you can break something down into a linear equation, you can finally solve it. And that's what factoring does. So let's see some other stuff here. There's a ball, again same thing, a ball reaching a certain height and eventually going down, striking the ground. Ball is pretty cool. When it gets very much important to hit at a certain target is when you have something like a missile taken off. Travels halfway around the world. You kind of want it to hit exactly at the right spot you're aiming for, right? So very important to have equations that can actually compensate for things here. Okay, but not launching missiles. There's a whole bunch of other stuff here. Notice this is manufacturing a tomato juice can here. Notice real quick, you see this little r squared right here? Again, that's this whole concept of things are not linear in our world. Things have surface area to it. Things have volume to it. So we have to figure out stuff. Even an ice skating rink. Again, the area here is not linear anymore. You got some circles in there. So now we have non-linear things. All right, volume as well. Let's see. And this little fun one here. Golden Gate Bridge. Notice these little cable lines. It's called a cable bridge because these cables actually hold this up, at least some of it here. Notice this right here is not linear at all, right? There's a curve to it. So how can you get a curve? Again, this is engineering here, but what curve would maximize the amount of weight it can hold? What is the best one? And that's what one of the things that they figured out in the Golden Gate Bridge. They figured out a little formula for this curvature, bless you, that would hold up the maximum amount of weight on a bridge, which is kind of cool. They had to do it by factoring. Okay. Okay, so again, a few little things here. Genetics. Notice this is not linear. It has a square in it. And again, this whole concept of things are not linear. Biology. Population models. They're not linear. They go up and down. They usually cycle through. As there's enough prey, the predator population goes up. As there are less prey, the predator population goes down. Anyways, kind of fun stuff. There's another one here. Anything that we can categorize by years of things going up, things going down, usually, again, it's not linear anymore. Therefore, we need factoring for that purpose. Okay, before we get to factoring, let's start off very, very basic. Let's get into number one. Close to number one. It's just the whole concept is factoring a number. So let's go all the way back to pre-algebra real quick. How do we factor down a 12 into its prime numbers? We go and we just say, okay, what two numbers multiply give you 12? 4 times 3. If we did 2 times 6, it would have been the same thing, right? Eventually, the 4 breaks down in 2 and 2. If we did it 2 times 6, the 6 would have broken down to 2 and 3. But this is a prime factors of 12. It's 2 to the second power times 3. That's exactly what we're going to do, is we're going to stick variables in there called x. Okay, and just real quick here, repeat of pre-algebra prime numbers. There's a listing of prime numbers here. And these are all snippets from your textbook as well. So if you want to follow along, you can literally follow along during lecture. And anybody know what page number we're on? Cool. We're on page 34 as of right now. All right, the other, let's see. In your textbook, do you guys have these little sticky notes along the side as well, or no? Yeah. Okay. Those are somewhat helpful as well. All right, so on page 34, there is a listing of prime numbers, just so you know what they are as well. Okay, but let's go on to then question number 1. Using these prime numbers here, can you break down 72 into its prime numbers, or we can say prime factors? All right, most of you guys are probably done here. At least more than half of you guys are done. And I think most of you guys did it by a factor tree, if anything here. I did it just by how the book did it here. So 72 is really 2 times 36. 36 break down into 6 times 6. And each of the 6's break down to a 2 and a 3. And then what we do is we gather all the 2's together. So we say 2 to the third power times, and then we've got two 3's here, so we say 3 to the second power. We good? And even on the online homework, you'll say start with the lowest number base. So you got to start, if you have a 2, you got to start with a 2. Then you move up yourself to a 3 and a 5 and a 7, whichever your lowest numbers are.
I did like different numbers, but I got the same answer.
Yep.
Okay.
So yeah, with you don't really need to do 2 times 36. 8 times 9 would have worked out exactly the same way. So as long as at the end we have the same exact prime numbers as products, that's what you want. Okay, how does this help us also? This whole concept of prime numbers or factoring, it helps us to reduce fractions as well. So reducing 126 divided by 210. And again, let's do this one together probably here. So on the online homework, the numbers are going to be bigger. They're going to be to the thousands and the 10,000s. What they really want you to do is to break down this number further here. So 126 is really 2 times 63. And that's kind of what you're doing, as opposed to just dividing by 2 each time, then dividing by 3, both top and bottom, trying to break it down into its prime numbers first. So break down 126 into its prime numbers. All right, let's see what I got here. I got 126 breaks down into a 2 times 3 times 3 times 7. In this case, with fractions here, I don't want to put it as 3 to the second power or something. I want to list each of these factors by themselves, because I'm going to start canceling these factors by themselves. $210. Again, try yourself here. Give you guys a quick minute here. let's see, 210. I know 5 would go into that. 5 goes into 105 21 times. That's cool. Then 21 breaks down into 3 and 7. Cool. Okay, so then what I'm going to do, I'm going to write each of those factors in order if I need to, or in order sort of helps here. So 2, 3, 3, 7 goes on top. 2, 3, 5, 7 goes on the bottom. Now I can cancel off anything that really makes a 1, right? Because 2 divided by 2 is technically a 1. All right, on the online homework, they're going to make you do it this way here because the numbers are so huge. They're like 57,893. I'm like, oh boy, what do I do? I got to break it down into its prime numbers slowly. Okay, so the 2's are gone. The 3's are gone, or one of the 3's on top is gone. And then 5 can't, and 7, yep, 7 is gone. So really, this breaks down into a 3/5 at the end of the day. Okay, again, 2 sort of very easy concepts, but having to do with factoring, and those 2 come from pre-algebra. But let's go on to now factoring as we do in algebra. Let's put in the variables now. And again, this is going to be a quick review of like 4 or 5 sections in in Math 61. We're going to do this in one single section here. So I think the first concept we learned about factoring was this whole concept of factoring by grouping. And factoring by grouping happens when you have 4 terms or more. And we'll do like a quick review of everything here in a bit here. But let's put the pieces, let's look at each of the pieces, then we'll put all the pieces into a puzzle. So the first concept is factoring by grouping. I see 1, 2, 3, 4. There's 4 different pieces here. So what I'm going to do to make it easier myself, I'm going to break it up. And you break it up by putting them in pairs. So you can set up 2 parentheses, and you always want to have a little plus sign in between the 2 parentheses. Okay, so the first 2 terms, the 2ax plus 4bx goes into the first parenthesis, and the last 2 terms go inside the second parenthesis. So instead of having to factor the whole entire thing at once, what we're doing is we're factoring by couples. Okay, out of the first parenthesis, what gets to be factored out? Yeah, 2x, that's right, because a 2 and a 4. So 2x goes out. Leftovers? A plus 2b is perfect. All right, out of the second parenthesis? Yeah, just a y, that's it. Okay, so y goes on the outside, and magically, not really, mathematically, what happens is you get the same exact parenthesis as leftovers. Okay, so now what we're going to do, one more step, and this is the tricky one here. So notice both of these terms are exactly the same. So then I say to myself, what can I factor out of this term and this term? Okay. A plus 2b. Of course, that whole piece gets factored out. And the leftovers out of the first term is 2x. Leftovers out of the second term is the y value. Okay, and then a question comes up. Mr. H, can I have 2x plus y times a plus 2b? Yes. Sort of interchangeable. Just like, what are the factors of 21? You could say 3 times 7 or 7 times 3. It doesn't matter which way you really say it. So same thing here. The factors, the parentheses don't need to be in any specific order, but the terms themselves have to be there. Okay, that was one portion of factoring which you guys learned. The second one was this whole concept of something called guess and check. There's the other part that we did, or the trial and error method. And again, we're just sort of reviewing pieces of factoring. So what makes this difficult is because you have this little 6 in front of the 2x. If you didn't have that 6, life is so easy. That was math. That was so long ago. That was like math 61. So what happens if you have the 6 in front? Well, we have to do the trial and error method. So here how it goes. We have to figure out a way to factor down to 6x squared. We look at the first number. There's actually 2 different ways, isn't there?
I know this way, it's just I kind of forgot the steps to it. Like the X and then like you do A, B, and then, you know which one it is? That's the one I like best.
Okay, so what we do, we figure out all the different possibilities of getting a 6x squared, which is 6x times x. We also, hey, hold on, there's another way to do it too, huh? Isn't there also a 2x times 3x? So there's actually 2 different ways to get a 6x squared. Then we think about all the different ways I can get a 4 at the end. So 4 is maybe like a 4 times 1, or a 2 times 2. That's right. So okay, so let's go for it here. This is why it's called trial and error. Let's go with the first one here. Let's assume it's 6x plus 2 and x plus 2. So it was 6x times x in front and a 2 times 2 as our factors of 4. All right, we figured out how to get the 6x squared because that's the numbers that we put down. We also know where we got the 4 from is the 2 times 2. The only thing that's missing is that's 11x. Do we have an 11x in the middle? And what we have to do is we have to check the outside terms and we have to check the inside terms. So outside term 6x times 2 is 12x and 2 times x is 2x, and does that add up to 11x? Not today. Okay, not any day, because that's going to be 14x. Okay, only other choice would be a 4 and a 1, so let's do that one here. So how about the 4 next to the 6, and then the 1 next to the x? Will that give it to us? Oh, so close. And I heard some people say it 10x, that's right, it's 10x, because 6x times 1 is 6x, plus 4x makes 10x, not 11x. What a bummer. And again, this is the more difficult one for Math 63. I'm sorry, for Math 61. All right, the thing that we can do with the 4 and the 1, we can switch them over. So how about if the 1 goes next to the 6x and the 4 goes over to the end here? Will that finally give me 11x? I don't think so. Huh? That's going to give me actually a 25x, right, as I check the outside terms and the inside terms. Not even. Okay. And you have to do it sort of in an orderly manner. And again, didn't give you an easy one. This is a difficult one. Okay, so that's all the different possibilities of a 6x times x. So now go back to this one now. 2x times 3x. And we're going to try to do the 2 and the 2 again, because let's plug in 2 and the 2 making the 4. And heard it already, 10x, that is 10x. 2x times x is 4x, and the 6x. Okay, now let's do the 4 and the 1. Let's see if that works. Does this one work? No, that's going to be a 14x. That's not going to work. Okay, let's switch the 1 and the 4, and then will this one work? Yes, there's my 8x on top, 3x on the bottom, so if I add those guys up, it gets me an 11x. And of course I saved it for last. And again, this is the more challenging factoring for Math 61. I didn't give you an easy one for Math 61. Assume you guys know those already, and I think you guys have lots of practice on the homework. Let's see, what's a few things we can actually go a little bit faster on these here. I'll give you the little trick, okay? It's free, not even going to charge you for it, okay? This is like part of the class. No, not part of all classes of Math 63, just my class. Okay. Notice you have a 6, 11, and 14. Remember we talked about greatest common factors? For Math 6, 11, 14, is there a greatest common factor between these guys? I don't think so, huh? You can't factor out anything out of 6, 11, 14 that is common besides 1, right? Notice when we go to this one, notice you have a 6 and a 2. Notice you can technically factor out a 2 out of here, right? There should have been a 2 in front there, right? Do you see how this one has a common factor, but this one doesn't? We good? So whenever you look at these here, a way to shorten things out is to think about whenever you put in the numbers, these guys always have to be, they can't have a common factor inside the factors themselves if there's no common factor in the beginning. We good? So technically we should have not even done this one. How about this one? Should we have looked at this one or no? Nah, because the 6 and the 4. That should have been off the list. Should we have looked at this one? This one we should have looked at, right? Because there's no common factors between 6 and 1 or 1 and 4. Cool. So technically we should have tested this. How about this one? Should we look at this one? Nah, because the 2 and the 2. Yep. How about this one? Nah, 2 and the 4. So really, the only ones we should have tested is the last 2 each time. Cool. Those are the only ones that did not have any common factors inside the parenthesis. So instead of doing 6, we could have just done 2. Cool. Free of charge. It's cool. Okay. So we just looked at the two something called the processes. Factoring by grouping was a process. Trial and error was a process. This is a process. This is not a formula. This is something that you go step by step. You gotta have to sort of know the steps. We good? But now let's jump to the formulas that we know of. So first is the difference of two squares. It's a squared minus b squared. This is a formula now. And with formulas, you have to sort of make sure it sort of jumps into that formula correctly here. Again, these are the formulas for Math 61. And I sort of listed all three of them here. Previously, we know these three formulas. We're going to work on just this formula right here. But let's see real quick here. You know, we're going to write all this down. Let me do it this way here. We're going to write down all this stuff later anyways, so no need to write this down yet. Let's not do that yet, sorry. The only formula that you probably need to write down is this one right here, the a squared minus b squared. We're going to write it down anyways. That was when we're going to summarize everything. Okay, so let's go down here. We've got 9x squared minus 48. I'm sorry, 49. The special formula is this right here. Whenever you have a squared minus b squared, if you have a difference of two squares. So the two squares are at the end, you got a minus in between, and we got it right here. So now the question is this 9x squared a perfect square of something? Yeah, it's a perfect square of 3x. Is the 49 a perfect square of something? Yeah, 7. Okay, so if you can fit it into this formula, the answer will just be it's a 3x plus 7 and then a 3x minus 7. All right, and you know what? Let's do this here just so we got it. If you wanted to write down a formula just so you have it on your notes, just write down this formula right here. That's the one you want out of this set right here. Just a squared minus b squared equals a plus b, a minus b. All right, and it's a question that's going to come up here. Notice there's only two terms here because the middle term has just got canceled out, right? And the reason why it got canceled out is because the signs are different right here. So notice real quick, 3x times negative 7 is going to be what? Negative 21. And 7 times 3x is going to be? Positive 21. So a negative 21 and a positive 21 will cancel off. That's why the middle term cancels. It's gone because they're just opposites. And the reason why they're opposites because of the opposite signs right here next to the 7. Okay, that's one formula. Next one. This one you may or may have not have seen in Math 61. This is a difference of cubes, but also with cubes you can actually also have a sum of cubes. So here's a formula. Go for it. Probably write it down just so we've written it down twice here. So with cubes, the funny thing there is you can actually have a sum of them as well as a difference of them. Can't do it with squares. Kind of has to do something with the whole concept of, let's see, positive times a positive times a positive. If you have 3 positives multiplying together, you can get a positive. If you have 3 negatives multiplied together, you can still get a negative, right? Negative times a negative times a negative, you can still get that negative in there because of there's 3 of them this time. So, okay, let's look at an example if we have one here. Okay, but before we do it, look at the example here. There are those few students that say, Mr. H, this cannot possibly happen. You can't have this multiplying and actually just gives you a cubed plus b cubed. It's impossible. So we're going to do something that we have not done in Math 61, which is verify an identity. We're going to verify that this is true. And let's just take the top one because it's really not. The bottom is not that big of an issue here. We're going to verify that a cubed plus b cubed is equal to a plus b times a squared minus ab plus b squared. So just the top one, just this one right here. Not going to do the bottom one. So let's rewrite a plus b, a squared minus ab plus b squared. We're gonna multiply this out. Because remember, factoring is just the reverse process of multiplication. So let's FOIL this completely out. Let's just see. If you can do it ahead of me, that's fine. But I'm going to multiply the a times a squared. A cubed, that's cool. Okay. A times negative ab. Negative a squared b, I heard. Yep, perfect. And then let's see, a times b squared. Okay, and another little trick here. Instead of kind of keep on going horizontally, what we can do, as we start multiplying the b times a squared, we can do is we can sort of line it up under each of the ones that are similar terms, or like this here. Let's b times a squared will give you a squared b. So we'll line it up sort of underneath its like term. So then we can just add down and be done. So how about b times a negative ab? Well, it gives you negative ab squared. And b times b squared is a positive b cubed. And now let's just add down. Cool. So I got a cubed on this side, and what happens? The middle cancels. The two middles cancel here. And we're left with b cubed. Hey, we verified it. We know that works. Now if we go reverse, that means we know that a cubed plus b cubed is equal to all this here. We're good? We're going to be doing a little bit more of this kind of stuff in Math 63. In Math 61, we just sort of learn how to use the formula and that's it. As opposed to Math 63, we're going to do a little more verification of formulas. Okay, but let's get to our problems here. Can we factor x cubed plus 27? And again, it just has to fit the formula. If it fits the formula, we're doing great. And with me here, or ahead of me, whatever you like. So x cubed, what is being cubed to give you x cubed? X, of course. What cubes to give you 27? 3 is good. Yep, it fit the formula. This is the sum of two cubes. So again, if you think about it, a is really our x, and the b is really the 3. And so if you use that formula from the previous slide, and see if we can sort of connect them here. So again, the formula is, it's a plus b, and this time it's going to be x plus 3, right, for our first parenthesis. Our second parenthesis starting off with squaring the a value. In this case, now we're going to square the x value. It's always the opposite sign first, right? And then the a and the b multiply together, so x times 3 is 3x. Plus, and the b being squared. So 3 squared is 9 is good. And there's our final answer there. Okay, everybody good there? Yeah, I think that'd be good enough. All right, so now let's just jump to this here. This is from the previous textbook. I think your book, see, your book doesn't cover it. I wish it did. It writes it down into steps in English, but that doesn't make sense in English. Let's do it this way here. This is the general strategy for factoring. And again, if you got this down and you know this is the steps for factoring, and they work all the time. They're in sequence. So if you can write down this for me here, if you have any questions on how to write down stuff, go for it. But first step of factoring is finding the GCF, and this is called the greatest common factor. GCF, greatest common factor. And then step 2, that's kind of cool. There's only 2 steps to factoring. It wasn't that difficult. Let me put this one as greatest, so we have it. Greatest common factor. Okay, and then step 2, it all depends on how many terms you have. Step 2 of factoring, if you have 2 terms, it has to be a special form. And we just covered those just now. It's either a difference of 2 perfect squares, sum of 2 perfect cubes, or a difference of 2 perfect cubes. And they factor into these right here. If they have 3 terms inside them, it may be a special form. Doesn't have to be. So we're going to check this. This is still for Math 61. These 2 forms are for Math 61. If it doesn't fit a special form, then we're going to do it by the trial and error method. Right, if it has 4 or more terms, then we're going to do that little grouping method that we reviewed earlier. So just a quick correction here on 2C, it should say 4 or more terms. So 4 terms, 5 terms, 6 terms, that's great. That will work out. We're going to just use the grouping method at that point for that. Okay, so let's do some practice problems. Quite a bit of practice problems here. Let's sort of get used to this whole concept of factoring here. So number 8. Let's do this here. You try it first. After half a minute or so, I'll put up the answer, see if you guys got it correct, and then we'll go through any questions if you have any. So half a minute, all yours. For each of these problems here, they are specifically set so that each one sort of teaches you a different rule. They're sort of not sort of practice problems. They're just teaching you a different concept each time. So real quick, you're looking at this here. Is there a greatest common factor? Absolutely. How about a 3x cubed, right? So real quick here, if you factored out a 3x squared, not good. That's what we call it, the greatest common factor. You got to factor out that the biggest factor that's in common, and if you don't, then you're going to get the rest of the problem wrong. All right, leftovers should have been 4x squared minus 9. At this point, you should recognize this is a difference because of the minus sign. Difference of 2 perfect squares. Difference of squares, one's a 2x, one's a 3. So how about final answer? 3x cubed still on the outside, but you have a 2x plus 3 times 2x minus 3. Cool. Next one. 9. Is there a greatest common factor, and what is it? 5x squared has to go on the outside. The leftovers then would be x squared minus 6x plus 9. Okay, this one is the one that you can do the little x box on, right? Two numbers, let me do it up here. Two numbers multiplied to 9, add to negative 6. Cool, yep, negative 3 and negative 3, that would work, yep. Or you can recognize this as a perfect square trinomial. We'll get to those as well. But eventually you should get something that looks like this. Or you can write it like this. This is perfectly a correct answer. But you can also write it like this. Whenever you have repeating terms, you can just put exponents on top of that term for the amount of times it repeats. All right, since we're coming up on the break here, let me do this. Let's just kind of go through the rest of the problems together real quickly here. So number 10, 3y squared plus 75. Is there a greatest common factor? 3 gets to go out. Leftovers would be y squared plus 25. All right, does that break down any further? Ah, that's interesting. Let's go for it. Somebody said y plus 5 times another y plus 5. So if I do that, you get a y squared You get a 5y, plus 5y, right? You get another plus, ooh, hold on, we got a little problem. We can't do that because these guys are not going to cancel, huh? Cool, okay. Plus 5 minus 5. I'm doing this for a reason because this is where it gets sticky. We're learning something here. If you have a plus 5 minus 5, what's going to happen? You're going to get a y squared. You're going to get that minus 5y like you want. You get a plus 5y like you want. But if you multiply these guys together, you're going to get a negative 25. Bummer. So for the middle terms to cancel, you have to have opposite signs. But if you have opposite signs, you're going to get a negative times a positive, which should get you a minus here. We good? Hey, that's right. There's no rule for sum of two squares, right? There's sum of two cubes, but there's no such thing as a sum of two squares because of that right there. Okay, we're good there? Haha, gotcha. Okay. This one. This one, whoa, there's a 12 in front here. So that means it could be a 12a times a. Could be a 6a times 2a. Gee whiz, there's a lot of different. Or it could be a 4a times 3a. 3 different possibilities for the first term. And to get a negative 4, let's see, sheesh, that's either a 2 and a negative 2 might work, right? Or a negative 1 and a positive 4, but then also you got a negative 4 and a positive 1. All right, I give you a hint here. It's going to be the last set. It's a 4a times 3a. Why don't you guys try that? All right, real quick here. If we were going to try 12a times a, we'll go on the next slide here, which one of these would we not even try? Yeah, the second one, right, and the third one, right? No need to try those even. Right? Okay, off the set of 6a and 2a, which one of those can we not even try? Yeah, but this one. Yeah, that goes away, right? Because the 2 and the 4. That goes away because the 6 and the 4. They have something, and then this one. Hey, I didn't need to try any of the 6a times 2a. There's no need to because they all have common factors here. So when we get to the last one here, as we multiply that out, you get yourself a negative 13a. And that's exactly what we need for the middle. All right, another thing to mention here, and I should. What happened if, I just want to show you this real quickly here. This is from Math 61, but it would be good to repeat themselves. If I had this, if I had the sign switch, notice I have a plus 1 here and a minus 1 here. This is a minus 4 plus 4. Notice what happens if the signs are, I got the numbers in the correct position, but the signs are wrong. If that happens, guess what? I have myself a 16a. Yep. When I add these guys up, I give myself a positive 13, but I'm looking for a negative 13 from a middle term. So if the numbers are correct, let's see, and my number is the exact opposite of what I want, I just need to switch my signs, and I'm good to go for my answer. Okay, 4 more problems to go. And again, let's do these together if you haven't finished off for yourself. So for 12, I see a 6's in both. I'm going to factor out a 6. Now I'm factor out an x because I see x in this guy right here. Once I do that, now I have a x cubed plus 1. Hey, that little 3 gives it away. Now I'm looking for perfect cubes. That's going to be a perfect cube of x. And 1 is a perfect everything. 1 is kind of a good chameleon here. Fits everywhere. 1 cubed will still give you a 1. Alright, then I have to put it into a formula. So if you haven't memorized that sum of two cubes, probably should put it on a 3x5 card. But the answer should be x plus 1 for the first term. And again, squaring the x, putting a minus sign, multiplying the two terms together, x times 1 is x, and adding whatever this guy is squared, 1 squared is still a 1. Okay, 13. Let's see, multiple variables now. I got x's and y's at the same time. So first of all, I got a 9, an 18, and a 9. Ha, that's cool. I know 9's going to go out. Okay, and notice for our next set of variables, we look at each of the variables separately. So x to the fourth, x to the third, x to the square. It's always the lowest exponent. Good. So if you have x to the fourth, x to the third, x squared, it's just going to be x squared. Then I see a y, and a y cubed. So again, it's just going to be a y that's going to get to go out. So if you want to put a little asterisk next to this, just put lowest exponent on variables. Lowest exponent on variables. Okay, and then of course we got leftovers here, and that's the leftovers. And this one will not factor down anymore. All right, and the last two problems here. Factoring. Hey, I see 1, 2, 3, 4. That kind of gives it away. I see 4 terms here. That's going to be factoring by grouping. And again, factoring by grouping, we do that with pair of parentheses with a plus in the middle. All right, the first two terms go inside the first parenthesis, the last two terms inside the second parenthesis. And let's see, what do I get to factor out here? 8 into 24, 8 definitely gets to go out. How about an 8x on the outside? A minus 3 on the inside. With 10 and 30, a 10 gets to go out. And again, the same thing happens as a minus 3. All right, there's a little bit of a twist here to the grouping method here, just a bit here. So let's see. So the a minus 3 gets to go out, and we have an 8x plus 10. At this point, you think, I'm done, I'm done. And like, no, you're not, no, you're not. Because can you factor anything else out?
Why is it a minus 3 to the second? So you have 2 of them.
Uh-huh. We're not combining them together, we're factoring them out. So it's almost like a minus 3 got to be pulled out of both of these out. And the leftovers were ax and 10. Yes, out of the second parenthesis, there's still a factor of 2 in there. So with a factor of 2, oh, that's good too. Okay, 2 gets to go out, and usually we put whatever a monomial is, we put that in front, whatever. And then got a minus 3, we got that. Out of curiosity, if you look all the way back to the original problem, could we have factored out a 2 out of here originally? Yeah, that sort of tells you like, yep, we're heading in the right direction. We should have been able to factor out a 2. Okay, last problem. We'll do this kind of quickly here. So let's see. x plus 2, hey, that's weird. X plus 2 is here, x plus 2 is here, x plus 2 is here. We're going to factor out a whole factor of x plus 2. So on the outside, x plus 2. And then we got leftovers. For the first term, it's 5x squared. For the second term, it's a minus 8x. For the third term, it's a minus 4. And then the only question is, does this factor down some more? 5x squared is going to be a 5x times x, and then we're going to try a few things here with a negative 4. Let's see, it could have been 2 and 2. I'm thinking maybe 2 and 2 because 2 times 5 is 10, right? And I can subtract out another 2 out of it somewhere. So let's do this here. A minus 2 here because that will produce a negative 10x. And plus 2x would produce a negative 8x that I wanted in the middle. Alright, the stuff that we're not covering in chapter 1, which is still important, is order of operations. Hopefully you guys go back and sort of review that if you need to. 1.5 is all about quotients. All about quotients and exponent rules. So again, if you have the extra time, look at that. And that's probably the only major sort of stuff that's still left in chapter 1 to cover, which we won't have time for in this semester.